In this video, we're going to work through another example. Instead of calculating molar solubility, this time we'll know the molar solubility, and our goal is to calculate the KESP, or the solubility product. So our problem states to determine the solubility product of lead 2 bromide. Its molar solubility in water at 25 degrees Celsius is 1.05 times 10 to the negative 2 molar. So I'm going to, now that I've read that, push this up a bit. There we go. That molar solubility is right here. So that's going to correspond to either S or X, depending on how you think about the problem. So I think the first step on this one is to start with our equation, our reaction that's occurring. So lead is going to be a +2 ion, and that's told to us through the 2 here. And bromine will be -1. And so we're going to have lead with Br2 as a solid. And that'll be an equilibrium with a bit of the dissolved ions, the lead +2 and the bromine ion. To balance this equation, we're going to need a 2 in front of the bromine. Now I'm going to approach this like an ice table again, except I kind of know the end value for X or S instead. But looking at an ice table, we don't consider the concentration of our solid lead bromide because it's a solid. It's not dissolved. It doesn't have a concentration. And initially, when it's put in water, there would be 0 of our ions around in solution. Now, as the equilibrium was established, the change we would see is we would see an increase in the amount of lead ions that are in the solution and an increase in the bromine ions. So it'll be a +X for lead +2 because there's a 1 coefficient in front of the lead, and +2X for bromine. Now this X is the 1.05 times 10 to the -2. At equilibrium, that's going to equal, so if this is X and 2X, 1.05 times 10 to the -2 for our lead, and 2 times our 1.05 times 10 to the -2 for our bromine ions. So that 2 times 1.05 will give me 2.10 times 10 to the -2 molar. Now to calculate the solubility product, I need to set up my equation for the concentration of my lead +2 and the bromide ions. And that's going to be squared because we have a 2 coefficient in front of the bromine. And so that 2 coefficient shows up here in our change, but it also shows up here in our expression for solubility product. So plugging in my values at equilibrium, I'm going to have 1.05 times 10 to the -2 molar times 2.10 times 10 to the -2 molar squared. And plugging this into my calculator, I should get a value that is 4.63 times 10 to the -6. And I'm not going to use units on this because our equilibrium constants are unitless. So I won't use molarity or molarity cubed in this case.